So welcome to this segment of mathematics videos as we look at insulation. So I'm going to teach you concept about what we call as being the frustum. So the frustum. So that is what we are going to look at. So it's a full cone, but when the cone is eliminated, so when the cone is cut off, they remove the top part. What remains is what we call as being the frustum. But of course, sometimes they can ask you to find the height of the cone that has actually been removed, as in the case of this situation. For example, the question here says that given that e to x, in other words, the radius of the smaller cone is 4 centimeters and db is 12 centimeters, that is the radius of the bigger cone there is 12 centimeters, and d to e, the height of the frustum, is 15 centimeters. And then they tell you calculate the height AE of the smaller cone AXY. So that is AXY. So remember, this is the smaller cone that was removed. No wonder I've actually represented in dotted lines. Now what you can do to find the height of the smaller cone, you can compare the smaller cone. Let me say this is the smaller cone that I have there, and let me compare it to the entire larger cone that I do have there. So in this case, when I talk about the smaller cone, it is simply A, X, Y, and the entire larger cone is starting again from A, B, C. So A, B, C. So that is what you need to remember. So the radius of the bigger cone is represented by capital R, which is 12 centimeters, and the radius of the smaller cone represented by small r, which is 4 centimeters, as they told us there. So that is what you need to remember. So now, since they want me to find the height AE, let me say, let the height, the height, H, let the height in this case AE be equal to X. So I'm going to represent it by X. So meaning the height from here to there, I'm saying that let that be represented by X. Then what is the entire height? If the height from here up to there is represented by X, then what would be the entire height from here all the way to there? So it simply means you're going to add X plus 15. So it will be X plus 15 there. So the entire height is going to be X plus 15. So that is what you need to remember there. All right. So now we can use a similarity in order to find the value of X representing the height. So I'm going to start with the smaller one. I'm going to say that's the A part, the height of the smaller one over the height of the the whole full cone, which in this case is X plus 15, should be equal to the radius of the smaller cone, in this case the radius of the smaller cone, which in this case is equal to 4 over the radius of the bigger cone, which is equal to 12 there. So from there now I can simply cross multiply. That's what I mean. So when I cross multiply, it will be 4 multiplied by X plus 15, which is equal to X multiplied by 12. So 4 times X will give me a 4X. 4 times 15, if you multiply 15 multiplied by 4, that is going to give you a 60, which is equal to X times 12 will give you 12X. Now to find X, we can collect the like terms on one particular side. So I can, if I want to bring this 12X to go the other side, so it will be 4X minus 12X is equal to, when this 60 crosses the equal sign, it will become a negative 60. So how do I work out that? Of course, 4X minus 12X will give me negative 8X is equal to negative 60. How do I find in this case X? I'll divide negative 8. What I do this side, I'll do it the other side. So therefore, my X there is going to be, if you divide negative 60 divided by 8, that is going to give you a 7.5. And because all my dimensions were in centimeters, so this is going to be 7.5 centimeters. So meaning the distance in this case AE is equal to 7.5 centimeters. It simply means that I can also find the total height of the larger cone, which is from A to D. So from A to D, it will be a combination of 7.5 plus that 15. Remember, AE is 7.5 plus 15, and that is going to give us 22.5 centimeters. But what they wanted in the first place was simply for you to find the height AE, which I've actually calculated. Alright, so in the next one, the B part, sorry, I've just congested the place. It says the volume of XB, CY. So they want us to find the volume of the frustum. So how do you get the volume of the frustum? Well, for you to get the volume of the frustum, it's very simple. Let me show you how you can do it. Later on, I'll show you a simple method that you can use when finding the volume of the frustum. So to find, in this case, the volume of the frustum, as we call it, so when this upper part of the cone, the smaller cone, is removed, what you are remaining with is what we call as being the frustum. So to find the volume, you can say the volume of the frustum is simply equal to, let me say volume of frustum is equal to volume of the bigger cone, let me say bigger cone, VB, minus the volume of the smaller cone. Now if you remember the volume of a full cone, it is simply given by 1/3 pi the bigger radius squared multiplied by the bigger height, minus 1/3 pi the radius of the smaller circle squared multiplied by the height. So that is what we are going to do there. Of course, you can actually try to to work out this. If you want, you can simply factorize that. There's basically no problem when it comes to that. But what we can do is that we can just work out it is going to be 1/3 multiplied by pi, which they have given us 3.142 multiplied by the radius of the bigger cone, which is 12, but raised to the power 2. And what was the height A to D? Remember, we got that one as 22.5, so it will be 22.5. Okay, whatever that we get from here, we subtract the volume of the smaller cone. So the volume of the bigger cone minus the volume of the smaller cone. So that is going to be 1/3 multiplied by 3.142 multiplied by the radius of the smaller cone, which is 4 squared, times the height of the smaller cone. Remember, we got that one to be 7.5. So we can work out that on the calculator and try to see. So it will be 1/3 multiplied by 3.142 multiplied by 12 raised to the power 2 multiplied by 22.5. So if you look at the value that I'm getting, so the volume of the frustum will be equal to the volume of the bigger cone is 3,393.36 minus, so you can also work out the volume of the smaller cone, 1/3. So 1/3 multiplied by 3.142 multiplied by 4 squared multiplied by 7.5. So what are we getting there? I'm getting 125.68. Then you can simply subtract that so that you can know the volume of the frustum. So it will be 3,393.36 minus 125.68. So basically that will give me 3,267.68. And because this is the volume, it is supposed to be in cubic centimeters. But remember what the questions tell you, leaving your answer to 3 significant figures. So to 3 significant figures, I'll just count 1, 2, 3 and look at the number in front. So it is therefore going to be 327. And remember, before the decimal point, that number that you have rounded off, you replace it by 0 to maintain the place value, and that is going to be in cubic centimeters. So once again, for you to get the volume of the frustum, it is the volume of the bigger cone minus the volume of the smaller cone, and that is going to give you. So when you subtract the volume of the bigger cone minus the volume of the smaller cone. That gives you the volume of the frustum. Please watch out for my next video. I'll show you a simple method of how you can get the volume of the frustum.